Let's go ahead and discuss EIGRP terminology. EIGRP terminology is one of the most important topics in EIGRP, and the reason is when you go into your router and you type show IP EIGRP topology, and when you see the networks and the calculations of the metric, it is based out of this concept that we will cover in this slide. And in this slide, basically, as you can see, I have defined the terminologies that are in used here. One is the successor route. The successor route means that the router with the lowest metric to reach the destination, that will be the successor route. Successor is basically the next hop router in the successor route, and that we can determine by calculating the feasibility distance. Feasibility distance, this is calculated locally by the router considering the lowest metric path to the destination. So basically each router will calculate its feasibility distance to the destination network, and this is something I will show you. Very simple, not to worry. Reported distance. Reported distance is the distance reported by the neighboring router for that destination. Now this is something I have put in most of the topics that are about the reported distance. The description is a little bit vague, and this is why I have put in here, and the reported distance is usually what the neighboring router is reporting back to the actual router that is looking to send a packet to the destination network. The other two conditions that are basically for guaranteeing a loop-free network is the visibility condition as well as the feasibility successor. These two conditions, if they are calculated properly, it guarantees that the condition is met and a backup route is there, as well as a feasibility successor is there in the network. And this is what we will calculate hopefully in this topology that I am giving in front of you. So let's go through the topology first of all, and let's see how we calculate the feasibility distance first of all, right? So from R1's perspective, this is the destination network here, which is directly connected to this router. So from R1's perspective, the feasibility distance here is, it's in front of you here, 1250. And what about the reported distance? Reported distance will be 0 here. The reason is this network is directly connected and there's no other router here that's reporting to R1 about the reported distance to this network. So it's clearly and it's logically understood that this is 0 for now because there's nothing else reporting to R1. Right, with regard to that network. Now if you come here to R2, the feasibility distance will be this value plus this value, which is the link metric, and here the feasibility distance will be 3,800. If you have a calculator, you can calculate it yourself. If you add 2550 to 1250, you'll get 3,800. The reported distance is what R1 is reporting to R2, and that will be 1250. Okay, that's the reported distance. Now if you come to HQ, the feasibility distance, when you add this much to this 3,800, it will be 4056, and the reported distance will be, right, 3,800, because this is what R2 is reporting to HQ. To reach this network, R2 is reporting 3,800, and that's what the reported distance is. Now, if you come down here, the feasibility distance from R3's perspective, when there's a packet coming from edge Q, it's going to be 5,106, and the reported distance is going to be 4056, right? Now, from R3's perspective, if it wants to reach the destination network, it will have another route advertised to it from R2, right? So feasibility distance here will be 5050, and the reported distance would be 3800, right? The conditions that I want to basically bring about is that is to see this condition, feasibility condition. So the feasibility condition means that there should be a backup route to the destination if it's getting two advertisements, and the condition specifies clearly that the reported distance of the advertised route, which is the second route, should be lower than the best route feasibility distance. So as you can see, this reported distance here is 4056, and it is clearly lower than the actual feasibility distance that this route chose as its successor route. So basically, when you do show IP EIGRP topology, you will see two routes. One is the successor route, which is the distance that's going like this, and the other route that this router will have will be coming from here, right? And this will be its backup route, right? So if this link fails, then this link will be will be basically replacing this link, and this link will be its backup route, and the packet to the destination will go over this way, right? So these are the conditions that you are looking at. So let's go over it again. Successor route means the best route, which will have the lowest metric to the destination. So from R3's perspective, the best route will be this way, from here to here. If you calculate, this will be the best route, right? But if it cannot go this way, because the feasibility distance from here, from this perspective, will be 6,100. Sorry, my writing is not good because my pen stopped working all of a sudden. And the reported distance, if you look here, will be 5050, right? 5050. So the best route will be through here, whereas the backup route will be through this side, which is going to be what we did here, which is the feasibility distance from here and the RD distance. The RD distance is lower than the best route that's calculated by R3, and so you will see two routes in the show IP EIGRP topology. And hence this guarantees that there is no loop on the networks, right? Why there's no loops on the networks? Because if you look at this condition and this condition, the RD is higher than the feasibility distance here. EIGRP will not accept this type of advertisement from here at all. And this will be basically guaranteeing that the HQ router will not have any loop in its advertisements. And that's the important part about EIGRP. I hope this clarifies the EIGRP terminology and how EIGRP chooses the best backup route for a router. So in this topology, I've shown you how R3 is calculating its feasibility distance or a successor route to the destination, as well as how it calculated the feasibility condition for a backup route, right? So feasibility successor for R3 is going to be through this link going up, and the successor route is through this link. So basically, let me change the color here. So the successor route is going to be from here all the way here. That's the successor route. And the feasibility successor for R3 will be from here all the way here. Right? That's the backup route. On another condition here that we seen also is how the router maintains loop-free network. So when we looked at from HQ perspective, we noticed that the advertisement that HQ was getting from R3 was not acceptable because the reported distance was higher than the actual feasibility distance, right? So this type of condition is not accepted, and that's how EIGRP maintains its loop-free network. I've liked it and clarified the points. Thank you very much, and I'll see you in my next topic.